after we have established idempotency, we want to show that the Young operators are actually primitive idempotents after suitable normalization. So primitivity is what we want to show now. And to this end, we have to sandwich some group algebra element Q between two copies of our Young operator and show that the resulting thing is still proportional to the Young operator for all Q here. So what's that? That's S lambda P, A lambda P, row symmetrizer, column antisymmetrizer, Q, S lambda P, A lambda P. What we already saw, this here in the middle is just a linear combination of group elements. So what we have to study is really, so the whole thing is linear combinations of terms of the following kind, and these are the terms we have to study. So that's S lambda P, and then let's say some other permutation Q tilde, A lambda P. But these are the things we just studied. We saw that by introducing this additional swapping of lines somewhere here in the middle, sometimes we will get 0, and if we get something non-zero, and sometimes we do get something non-zero, what we get is always the Young operator itself or minus the Young operator. So that was our criterion for primitivity, and we showed this. This expression here is always proportional to E lambda P for all Q. And finally, we want to show that the irreps generated by two Young operators for two Young tableaux of the same shape, so same diagram, different tableaux, same shape we're drawing, but writing the numbers in these diagrams in a different way, they are equivalent. Well, and in order to show this, recall that the E lambda P here, that is just E lambda conjugated with P. So that's P, E lambda, P inverse. And now we can look at this thing here. Let's say we look at E lambda P times P times E lambda, and then the P inverse and the P from here cancel, so we get P E lambda, but E lambda is already is idempotent, so it's just eta times E lambda, and then we have P times E lambda, and that's non-zero. And that's what we have to show. We have to find one way, something we can sandwich between the two idempotents such that we get something non-zero, and then we know that the irreps generated are equivalent.